Good morning, students. Today I am going to take your class Data Warehousing and Predictive Modeling. So, title consists of two different words: data warehousing and predictive modeling. So, we will discuss these two things in this course. The course title is Data Warehousing and Predictive Modeling. Course type is theory. Course code is E1PY301T, and this is for MCA course. The learning outcome of today's lecture is, at the end of this lecture, student will able to define data warehousing and explain the applications of data warehouse. These are my session outlines. So it consists of introduction to data warehouse, activity 1, and then importance of data warehousing, applications of data warehousing, and activity 2, match the warehouse use case, finally conclusion. So these are the contents of your subject. The subject is divided into 4 units. The first part consists of data warehousing, introduction and design. This is of 8 hours duration. In this, I will discuss overview and concepts, data warehousing components, building a data warehouse architecture, infrastructure and metadata, data representations, principles of dimensional modeling, data extraction, transformation, loading, online analytical processing, OLAP, and multidimensional data analysis, and OLTP, online transaction processing. Second part is data mining, and in data mining we'll discuss pre-processing. This is also of 8-hour durations. In this, I will discuss steps in data mining process, data mining functionalities, architecture of typical data mining systems, classification of data mining systems, knowledge discovery in a database, KDD process, data pre-processing, data cleaning, data transformation, data compression and dimension reduction, principal component analysis, binning methods. Third part is association rule mining and clustering. In this, I will discuss market basket analysis, a priori algorithm, FP growth, frequent item sets and rule generation, clustering concepts, types of clustering, algorithms, k-mean, hierarchical clustering, DB scan, grid-based clustering. And fourth part is classification and prediction technique. In this, I will discuss different types of classification techniques like decision tree, naive-based classifier, rule-based, SVM, lazy learner like KNN neighbors, prediction model, linear and logistic regression, evaluation matrix, accuracy, precision, recall, F1 score, and confusion matrix. So these are the broad overview of syllabus of data warehousing and predictive modeling. So in this, we will discuss data warehousing first part, data mining second part, association rule mining and clustering third part, and classification and predictive techniques fourth part. So these are the broad contents of syllabus. The recommended textbooks are shown here. Data warehousing in the real world, Sam Annahori and Dennis Murray, Pearson Educations, along with data warehousing and data mining and OLAP, Alex Burson. So this is also a good book. So these two books are recommended for this course. Now, we will start with these questions. Have you ever wondered how Amazon, Netflix, or bank manage and analyze years of transactions data in seconds? So in few seconds, they can analyze all the data. Can you think how it is possible? So these are some opening questions. Can you see these three diagrams? This is the first diagram, this is second diagram, and this is third diagram. What is similarity between these three diagrams? So this is wood warehouse, and this is book warehouse like library, and this is data warehouse where data is stored. Do you think all the systems have similar technique for storing data? Which one is better and why? So at the end of session, you have to answer these questions. Now, we'll start with introduction to data warehousing. So a data warehouse is a centralized repository used to store large volume of historical and current data from multiple sources. It is designed to support decision making and business intelligence activities. Let us see a proper definition of data warehouse. A data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data that helps in decision making. So there are some key features of data warehouse. So the key features are it is subject-oriented, integrated, time-variant, and non-volatile. Let us see one by one. Subject-oriented means data warehouse is organized around major subjects like sales, customer, products. So this defines the subject. So what subject you are dealing. So this subject-oriented tells you about the subjects. If you are managing sales, so it may be sales department. If you are going to purchase something, you may be from customer department. So these are subject oriented. Next term is integrated. As name itself implies, integrated means it combines data from different sources in consistent form. Data may come from one source, it may come from other source. So data can be integrated in data warehousing. Time variant. Time variant means it stores historical data for trend analysis. Suppose you have a rainfall data. So suppose in 1990, there are some rainfall, like it may be 100 rainfall. Then in 2000, it may be 110. In 2025, it may be this. So It shows time related data. So this is time variant features of data warehousing. Non-volatile means data is stable and not frequently updated or deleted. So your data is stable. Once it is stored in data the warehouse, it is non-volatile. You can't change the data. So these are the four major characteristics of data warehouse. Now you have to do one activity based on these characteristics of data warehousing. So we can explain this with help of these diagrams. Subject oriented means organized around major subject like sales, customers, and products. So suppose you have sales data, so it may be from sales department. If you are customers, it may be from customer department. There may be some products. Next is time variant. Time variant means it stores historical data for trend analysis. We can see this data and we can say the trend is like it is in increasing manner. So we can find the trend. It may be increasing, it may be decreasing. So this graph shows increasing trend. Integrated means data can be combines data from different source into consistent format. The data may come from this different sources and finally it is integrated. So you can see there are different, you can suppose you are collecting data from YouTube, Facebook, WhatsApp, and all data are integrated together. So this is integrated form. You have collected data in integrated manner. So this is integrated. Non-volatile. Non-volatile means data is stable, not frequently updated. Means you are storing data permanently so that in future you can retrieve all those data from data warehousing. So these are the four major characteristics of data warehousing. Now let us see this a problem-based, case-based problem. In this, a large retail chain implemented a data warehouse to analyze customer buying patterns. Sales data is organized into different sections such as electronics, clothing, groceries. Data from various store branches and online platform is converted into a uniform format. The company can view sales trend from 2015 to 2025. Once sales records are stored in warehouse, they are not altered even if errors are found. Now, there are few questions and you have to identify the term from this case-based questions. So identify which statement in this case reflects subject-oriented characteristics. Second question is which statement reflects integrated, which statement reflects time variant, and which statement reflects non-volatile. So you have to find these four characteristics from the given scenarios. So these are the correct answer for questions. Next is benefits of data warehouse. So data warehouse can be used for better decision making. So we have many data, so you can take decision in better manner. Historical trend analysis, you can find out trend is increasing or decreasing or not consistent. Improve data quality and consistency. Data quality can be improved. Faster query performance for analysis. So you can perform query faster. So these are the major benefits of using data warehouse. Top applications of data warehousing are we can use in banking, we can use in insurance, manufacturing, healthcare, retailing, education, and public sectors. These are the real life examples of uh, data warehouse. We can use data warehouse in retail and e-commerce. So industry using Snowflake, Amazon, Redshift, Google BigQuery, banking and finance. The applications are transaction and risk data warehouse. You can use fraud detection, credit scoring, financial reporting. So industry is Teradata, Oracle, Exadata, IBM DB2 warehouse. They are using this. Healthcare can use data warehousing for healthcare, patient record and treatment history, predictive analysis, disease trend analysis. The companies are Microsoft Azure, SAP, Snowflake. So these are the companies using this. Telecommunications, call detail and network users, warehouse, churn prediction, network optimizations, cloud era, data platform, Teradata, Google BigQuery, they are using this. Government and public sector also using data warehousing, census taxations, citizen services, policy analysis, fraud detection, budgets. So IBM DB2 warehouse, SAP, BW, Oracle Exadata, logistic and transport, shipment and route optimization, fleet management, demand forecasting, reduced fuel cost, timely delivery, efficient logistics. Amazon, Redshift, Snowflake, Google, BigQuery, they are using a data warehousing to implement all these applications. Now there is one more case-based questions. A Mart, a nationwide supermarket chain, recently implemented data warehouse to improve its operation. Manager can compare sales data across regions to decide where to launch new promotional offer. Marketing team uses 5 years of customer purchase data to understand seasonal buying pattern and predict demand. Data from different branches, suppliers, and online orders is standardized into single consistent format, reducing duplicate or conflicting records. Analysts can run complex queries on millions of transactions in seconds, allowing them to generate quick sales performance reports during meeting. So these are column A benefit and its impact. So better decision making, historical trend analysis, improved data quality and consistency, and faster query performance. These are the options. You have to match correct answer from the given case scenarios. So these are the correct answers. We'll discuss all these case-based questions in more detail in regular classes. There are few challenges of data warehousing. The first challenge is data integration complexity, since data is in integrated forms, and so data integration is a challenging task. High implementation cost, implementing and processing cost is high in data warehouse. A scalability and performance issue. Scalability is also a big concern in data warehousing, ensuring security and privacy. So these are the major challenges of data warehousing. Conclusion, uh, a data warehouse acts as backbone of business intelligence systems. It provides unified, historical, and reliable view of organizational data. Knowledge of its component and architecture enables effective system design. Well-designed data warehouse supports better decision making and deeper analysis. They help organizations to maintain efficiency and sustain competitive advantage. This is a class assessment. In next lecture, I will discuss components of data warehouse. There are some post-class activity. You have to perform this activity after the class. With this, I am completing today's lecture. Thank you.